Welcome back to the chapter Congruence of Triangles for Standard 9. So the problem here is, if D is the midpoint of the hypotenuse AC of a right angled ABC. If AC is the hypotenuse, then the side angle opposite to the hypotenuse is the right angle. So angle ABC is equal to 90 degrees, and it's also given D is the midpoint of the hypotenuse. So that means AD is equal to CD is given. Now we have to prove BD is equal to half of AC. So we have to, the normal method, it is difficult to prove it. So we will do some construction, that is, we will extend BD to E in such a way that BD is equal to AD. Now we will consider these two triangles, triangle ADB and triangle ADC. Note angle. So here this side is there, this will become vertically opposite angles, and this side. These two sides are equal, these two sides are equal, and this vertically opposite angles. So we can say the triangle SAS, the triangles are congruent. So we will write AD is equal to CD, S, it is given. Then let us put this as 3 and 4. Angle 3 is equal to angle 4. It's angle vertically opposite angles. And then we have BD is equal to ED by construction. From this we can say triangle ADB is congruent to, now this side, then angle and this side. So here corresponding to this side is this, then the angle comes. So it has to be CDE. CDE by SAS criteria. From this we can say AB is equal to CE, and then we can also say angle BAD is equal to ECD, angle ECD, both are by CPCT. So BAD will be this angle 1, and ECD is angle 2, that is angle 1 equal to angle 2. Now we will consider the triangle ABC and BCE. We have done similar problem earlier. It was to prove some other result. It's the same method only. So now consider triangle ABC and triangle BCE. So with this, so we have here, if you take this triangle, we already proved AB equal to CE, and we know these two angles, this is 90 degrees. Okay, we have to prove some other properties too. Okay, we will do it here. Since 1 equal to 2, we can say AB is parallel to CE. Therefore, AB is parallel to CE. There is, reason is alternate interior angles are equal. So since if these two are parallel, then this angle and this angle will become co-interior angles. Therefore, angle ABC plus angle ECB is equal to 180. Co-interior angles are supplementary. Now we have this is 90, ABC is 90 is already given. So therefore, ABC is equal to 90. Therefore, angle ECB is also equal to 90 degrees. ECB is 90 degrees. Now for this we will use, so here triangle ABC, AB is equal to EC is side, already proved. Then we have angle ABC is equal to angle ECB, angle that is also already proved here. And then we have BC as a common side. BC is equal to, BC is side, common side. Therefore we have SA, SAS, the triangles are congruent. Therefore triangle ABC is congruent to ECB. Triangle ECB. SAS criteria. From this we can say AC is equal to BE. Now AC is equal to BE, CPCT. Now we can write AC as, we have to prove BD is equal to half of AC. So now we have to convert this BE into BD. So we can say BE is equal to, so AC is equal to half of, BE is equal to twice BD. By construction. Therefore BD is equal to half of AC. So in this figure, explain how one can find the breadth of the river without crossing it. So let this be the river and AB be the breadth of the river. So now we have to find a method to find the breadth of the river. So let us mark a point M on this this bank where the point B is there. So mark a point M on the bank of the river where BM is a straight line. Let O be the midpoint of BM. Then you join AO and extend it to N, so that AO and are collinear. So they lie in the straight line. Now join MN. Now we will take these to consider these two triangles. Because this is outside the bank, if you are able to find this length, if we are able to prove these two are equal, then we can measure this length and then we can say that is the breadth of the river. So now we will consider the triangle. So O is a midpoint, so these two are equal. And then you have these are equal. And this we have to consider this as the perpendicular. Always the distance is the perpendicular only we generally take. So AB is perpendicular to BM and MN is perpendicular to BM. Now consider triangle AOB and triangle MON. So in AOB we can say now we have this angle and this will become vertically opposite angles. So let this be 1 and 2, this is 3 and 4. So in AOB, in triangle AOB, angle 1 is equal to angle 2, 90 degrees. Then we have BO is equal to OM is side by our construction, and then we have these two angles are equal. So angle 3 is equal to angle 4, vertically opposite angles. So from this we can say triangle AOB is congruent to triangle AOB congruent to triangle NOM. NOM, it is ASA. So from that we can say AB is equal to MN. So by measuring MN, we can find the breadth of the river. Here the figure is a trapezium. The line segments joining the midpoints M and N of parallel sides AB and CD. So AB is parallel to CD, that means it is a trapezium, and M and N are the midpoints. So this is equal and this is equal. N is the midpoint of CD. ABCD, the line segments joining the midpoints MN. So this line MN is perpendicular to both. So that means MN is perpendicular to AB, MN is also perpendicular to CD. Prove that AD equal to BC. So let us write whatever is given. AM is equal to BM. DN is equal to CN. Then MN is perpendicular to AB. MN is perpendicular to CD. Now you have to prove AD equal to BC. So construction, join AN and BN. So we have to prove AD equal to BC. So if we take these two triangles, we accept these two sides, we do not have any other criterias, any other parts. So first we have to take these two triangles, because here these two sides are there. This is 90 degrees and this is a common side. So SAS, we can say the two triangles are congruent, from which we can say you will get these two are equal and these two angles are also equal. So consider triangle AMN and triangle BMN. So from AMN you can say AM is equal to BM side, it is given. Then angle AMN is equal to angle BMN. This angle, it is also given. And then MN is equal to MN, this side which is common. So from this we can say triangle AMN congruent to triangle BMN. That is SAS criteria. From that we can say AN is equal to BN. We can also say ANM, angle ANM is equal to BNM. So let us put this as angle 1 and this as 2. ANM is angle 1 equal to angle 2. So both is CPCT, congruent, corresponding parts of congruent triangles. Now consider these two triangles now. Now we have this equal, now we have this also as equal. Now we need the third, so it should be either a side or a angle. So this side is what we have to prove. So we have to get an angle here. So we know MN is perpendicular to CN and these two angles are equal. Therefore these two angles has to be also equal. So let us put this as 3 and 4. So we'll angle 1 plus angle 3 is equal to angle 2 plus angle 4 equal to 90 degrees. It is given. Now 1 equal to 2, angle 1 is equal to angle 2. Therefore, angle 3 is equal to angle 4. Now consider the triangle AND and triangle BNC. So we can say AN is equal to BN, side which has been proved. Then we have angle 3 equal to angle 4 is also proved. Then ND is equal to NC is given. So from this you can say triangle AND is congruent to BNC, triangle BNC. From this we can say AD is equal to BC by CPCT.